Alright class, today we're going to be talking about the segment addition postulate. So right off the bat, I'm throwing a word at you that you probably don't know in postulate. So let's figure out what that is first. So what is a postulate? It's a property that we're taking as a given. So in geometry, as you're going to see before too long, we're going to prove lots and lots of things that you may take for granted, but we're able to actually use mathematics to prove that these things happen, whatever it may be, all the time, every time, and that's what makes a good, solid proof. But to do that, we do need some given information. The points, the lines, the planes, we don't have to prove anything about those. Those are just our building blocks. That's why we learn those first. But we also have a few postulates that math just doesn't really work without them. We can't start completely from scratch or else we can't go anywhere. So we have to use these as part of our rules for our world. And one of those is the segment addition postulate, and let's find out what that is here in just a few minutes. Alright, so I'm back in Cami, and we're going to look at measuring segments today. So first thing, we've got these points A and B here, and we've got a segment between them. The difference between a line and a segment is that a line goes on forever, and a segment does have endpoints. We've got a couple different ways to write this, though. So if we've got the distance between A and B, we can write this as lowercase m and then AB. And we want to make sure we write a segment line above that. So the difference between the line symbol and the segment symbol is that the segment symbol doesn't have the arrows. It's showing that AB is a discrete distance. There is a stopping point on each end. Another way that we can write the distance between 2 points is just capital AB. So this is why I'm telling you that the symbols are important here. We've already seen 3 different things. Let's write them up here. We've seen AB with our line. We've seen AB as a segment. And we've also seen just the letters AB. And these mean different things. And if you're worried about grades and that sort of thing, yeah, you're going to get knocked off on some of these if you do them wrong. Because this on the left is a line. It goes on infinitely. It is the line AB. This one right here is a line segment AB, which means it has a stopping point on each end. And then over here is just AB, it's the distance between the points A and B. So this AB is actually a number. This is an object, left is an object, a line, segment's an object, but this one over here is a number, it's a distance. And then there's one more that we haven't seen yet, but since I'm here I may as well throw it out. So we could have AB as a ray, and a ray is a object that is infinite in one direction. So this ray right here would have an endpoint at A, and then it would go on forever in the direction of B. We haven't seen any of those yet, but while I'm here looking at symbols, we may as well throw it out. All right, so keep them separate. That is one of the hardest parts about this first unit of geometry is just there's a lot of terminology. I know I'm throwing it at you, but we got to be able to speak the same language if we're going to get anywhere. And part of speaking the same language is making sure we are using the right symbols, the correct symbols. Okay, so let's get back to work. Down here we've got AB, and we want to know how long that distance is. Well, A is at -1, B is at 3. You could count 1, 2, 3, 4. That's going to be the answer. Or if you know a little subtraction, you can say that 3 minus -1 is also a 4. So either way you do that, we get a 4. Okay, let's talk about congruent segments. So if AB, so again, that's a number, that's a distance, is equal to CD, then the segments are known as congruent. So the distances are equal. Distances are a number. They can be equal to each other. Segments, on the other hand, are congruent. We have a different symbol for that. I'm actually going to bust out my equation box here, and this is written like this. It is AB, and it's this symbol right here. It's an equal sign with a tilde on top, is congruent to CD. And let me move this up a little bit, and let's make it a little bigger too. All right. So again, there is a difference, and it's a very, very subtle difference, but it is important. AB is equal to CD. That means that the distances are equal to each other. Numbers are equal to each other. Over here, when we have congruent, we have segment AB, and I almost forgot this, and you can't forget that. Segment AB is congruent to segment CD. That's why they have the symbol on top of them. So objects congruent, numbers equal. That's the big difference. Like I said, it's subtle, but it is important. So let's move on. Let's talk about this segment addition postulate. It's something that we're going to take for granted, and I'm going to say this, and you're going to go, duh. I mean, this should make sense. It does make sense. If it didn't, then we couldn't do anything. Numbers just wouldn't work. So I'm going to go in here, and if A, B, and C are collinear points, remember that means that they're all on the same line, and B is between A and C, okay? So we got A and C on the bookend, B somewhere on the same line in between them. Then we can say that AB plus BC is equal to AC. So that seems like it's really obvious, and it is. It just means if we take this small segment and we add it to this slightly bigger segment, we get the entire segment. So we're talking distances here, we're talking numbers, but that's what the segment addition postulate says. And using that, we're going to be able to prove things later. But we needed a basis, and this is one of our bases. So let's do a couple examples here before we move on. We're not going to do everything on the page. I don't want to make the video too long, and I do like to talk a lot, as you can tell. So it says, use this diagram for questions 1 and 2. We've got P and R with Q between them. So we know right off the bat that PQ plus QR is equal to PR. We know that's true anytime we're using this diagram. So number 1 over here, it says PQ is 9 and QR is 28. We want to find PR. Well, 9 is PQ plus 28 is QR. That's going to be equal to PR. And you can grab your calculator or count on your fingers and toes, even though you don't have enough. And what you'll do is you'll get PR is equal to 37 units long. And that's all there is to it. Don't try to overcomplicate it. I mean, that's what it is. This is what the segment addition postulate is saying. Number 2, we can do it again. Let's see. This time we don't know PQ. So we can say that PQ plus QR, which is 17, is equal to PR, which is 21. And from the magic of algebra, which you learned last year, we know that we've got this equation here, and we can subtract 17 from both sides. So if I subtract 17 from the left, I'm left with PQ. And if I subtract 17 from the right, I'm just left with 4. And that is the answer. PQ is 4 units long. Speaking of algebra, let's do one more here. So EG is 71 units long, and we want to find the value of X. So EG, this entire thing, right here, the whole thing, is 71 units long. We know that EF is 8x minus 17, and we know that FG is 5x minus 3. So it looks to me like we can make an equation. We've got one variable, x, and we've got one equation. So we should be able to solve that. So I'm going to write an equation here. This will give you a chance to practice with Cami a little bit, doing stuff like this. Okay, so we know that EF is 8x minus 17. And we know that if we add that to FG, which is 5x minus 3, then we get EG, which is 71. Okay, very good. So let's move this up just a little bit so we have room. And what I'm going to want you to do on these is actually just keep making new lines. I know some of you can probably do a lot of this in your head, but I do want to see the work since you're not going to be turning me in actual papers. So the first thing I'm going to do is combine some like terms. I've got 8x and I've got 5x. I know that those add together to get 13x's. And I've got a negative 17 and a negative 3. So that means that I'm going to end up with a negative 20. I didn't do anything to the right side, so that is still 71. Okay, algebra tells us that next we want to add this 20 to both sides if we want to find out what x is. So if I add 20 to the left side, I'm just left with 13x. And if I add 20 to the right side, because if I add it to one, I got to add it to the other, I end up with 91. And then finally, we want to divide both sides by 13. And that's going to get us an x on the left side, because 13x divided by 13 is just x. 91 divided by 13 is, last time I checked, 7. And that's our answer. X is equal to 7. If you really want to, you can go down here and you can circle your answer so you know it's the answer. Let's double check our work. That's the beautiful thing about math. If there's something I want to get across your heads this year, it's that if you do some work, you should be able to back up that work. You should be able to prove that the work you did was correct. So let's do that. Let's substitute in this x equals 7 into these top expressions. So 8x minus 17. That is 8 times 7, which is 56. And if we take 56 minus 17, then I believe that is going to be 39. So 39 right here. And then we do the same thing over here. We've got 5x minus 3. So 5 times 7 is 35. 35 minus 3 is going to be 32. And if we did our algebra right, then 39 plus 32 should add up to the entire segment, which we were given as 71. And last time I checked, it did. So that's how you can check your work. You should never need me to tell you that you're wrong. I don't want to tell you you're wrong. I want to tell you you're right. But you should never need me to tell you you're wrong because you can just check it yourself. If you just substitute that number right back in, then you've got the answer right in front of you. Okay, let's do example 4, and by let's, I mean I'm going to have you do it. Now that you've done that, we're going to move down on the notes, and we're going to look at one more concept today, and it is called the midpoint of a segment, and the nice thing about it is it's exactly what it sounds like. So the midpoint of a segment is a point that divides a segment into two congruent segments. So we've got our segment, we put a midpoint in there, and then all of a sudden we've got two segments that are the exact same size to each other. So a line, a ray, or a segment that intersects a segment at its midpoint. So if we look over here, we've got midpoint B, and then we've got this line that goes through B. And the word that we're going to use for that is bisects. So a line, ray, or segment that intersects a segment at its midpoint is said to bisect the segment, and it is called the, wait for it, I'm going to blow you away, the segment bisector. Okay, the segment bisector bisects the segment, and bisect just means that we're going to cut it in half. So in the diagram to the left, we've got point B is the midpoint of, let's see, it's the midpoint of AC, and we want to make sure that we are putting a segment line on top of that. And line L, lowercase cursive l, is a segment bisector of segment AC. And again, I want to make sure I put my segment hat on there. Okay, so B is the midpoint, L is the segment bisector. So remember that a segment bisector is never just a point. It has to be a segment, a ray, or a line. Let's do an example here. So Q is the midpoint of segment PR, and we want to find the value of x. Well, I've got this 7x minus 17, I've got this 4x plus 2. Up above, I was given the whole segment, and this time I'm not. But I've got something that I think is even better. I know that Q is the midpoint. If Q is the midpoint, then that means that PQ and QR have to be the exact same length. And if those two segments are the exact same length, then I can set up an equation. Over here, I want to make this bigger. Let's go bigger. All right, over here, we've got 7x minus 16, and we know that that's going to be exactly equal to 4x plus 2. Boom. Okay, there's our equation. Now let's solve it. And there's different ways to solve this, obviously. Some of you like to combine steps. I would encourage you to put as much information down as you think you should, just because if you make an error, I can usually see it. If you just write the original equation and write the answer, then I don't know what you did, and it doesn't really help anyone. So first things first, let's subtract 4x from both sides. So I'm going to take this 4x, and I want to get rid of it on the right side, which means I need to subtract 4x from both sides. So 7x minus 4x is 3x. We have not messed with that 16 yet. And over on the right side, 4x minus 4x is 0, so we're just left with a 2. And now that I've got all my x's on one side, I want to get all my constants, all my numbers, over on the other side, which means it looks like we're going to need to add 16 to both sides. So 3x minus 16 plus 16 is just 3x. And then over here on the right side, we've got 2 plus 16, which is 18. Then one last step. We've got 3x equals 18, which means that we want to divide both sides by 3. And we get an x that is equal to 6. And that is our answer. But again, we can double check it. So let's do that. So we've got an expression here on PQ, 7x minus 16. So 7 times 6 is 42. And then if we subtract 16 from that, I believe we're going to get a 26. And then QR, 4x plus 2, 4 times 6 is going to be 24, and we're going to add 2, which is also 26. So I'm pretty confident that we did our algebra correctly, and we're good to go. Okay, so last one, I'm going to have you do it yourself. H is the midpoint of GI. Find the segment length of GH. Go.